even. No earnings, no loss. So clearly, if you decide not to advertise, you'll never lose money. But at the same time, the maximum earnings are $50,000. Let's look at this problem from two approaches. One using probability and one not using probability. First, we'll apply 3 decision rules that do not use probability. We'll call them maxi-max, maxi-min, and mini-max regret. Then we'll go into probability rules. According to the maxi-max rule, we assume the best will happen and maximize the best payoff, or maximize the maximum.
Yeah. Drop
And this is typically what your optimist will do.
Right. Trust me, I know I'm right on this one. Okay, bye-bye. I'm sure things will always go well, so I would ask myself, what's the most I could make in each case? I'd first identify the maximum payoff for each decision and add a line to the table. So I'd look at the chart and see what's the most I could make in each case. According to the chart, if I advertise, I could make $200,000. If I don't, I could make $50,000. So I would select to advertise because I could make the most money. This is the maxi-max rule.
Under the maxi-min rule, we assume the worst and try to maximize our payoff or minimize our losses.
ITT was at
And this is what your pessimist does, always assuming the worst.
Gotta be wrong. I'm sure things will go badly. So I ask myself, what's the most I could make in each case when things are at their worst? I'd add a line onto the table to identify the minimum payoff for each decision. If we advertise and things go badly, I would lose $100,000. If we don't advertise, the worst I could do is lose nothing. So I would decide to keep my losses at a minimum and not advertise. This is the maxi-min rule.
The third rule is mini-max regret, which says simply that we minimize our opportunity losses. And this is what the go-getter or real ambitious people do when they're looking for
this morning, sir.
an opportunity for advancement.
Yes, I
or
felt
raise.
that your decision on the Waterman portfolio was one of excellence. I wouldn't have done it any differently. Okay, sir. You too. Bye-bye. I want to show my boss that I'm making the most of my opportunities. So I can start by developing a regret table. I do this by figuring for each economic condition how far the payoff is from the greatest possible payoff given that economic condition. So if I don't advertise and there is economic growth, I'll be $150,000 away from the greatest payoff, or I will have lost the opportunity to make $150,000. Mathematically, 200 minus 50. If I do advertise, I'll be $0 away from the greatest payoff, 200 minus 200. I can do this for each economic condition, ES and ER. I'd add a line onto the regret table to identify the maximum regret possible for each decision. Then I would elect to advertise because the most I'll regret if I don't is $150,000, and the most I'll regret if I do is $100,000. To keep my regrets or my lost opportunities at a minimum, I decide to advertise.
These 3 decision rules do not consider probability of growth, stagnation, or recession. Going back to our original payoff table, what you really would like to know is which event will occur. Will you have growth, stagnation, or recession? If you think growth or stagnation will occur, you will advertise. If you think recession will occur, you do not advertise. So we come to a 4th decision rule, which will use probabilities. The expected value rule simply works as follows. We multiply the payoff for each outcome by the probability of that outcome, and then sum respectively, for each decision. By using this rule, we can take into consideration the probability that economic growth or stagnation or recession will occur, and then compute the expected total payoff for each decision. For example, let's assume that reliable estimates claim that economic stagnation has a 0.7 probability, economic growth has 0.2 probability, economic recession has a 0.1 probability. We begin by assigning these probabilities to our conditions in the payoff table. We then calculate our total expected value for each decision across all possible economic conditions. The formula now looks like this. Expected value of sale without advertising is the probability of economic growth multiplied by the respective payoff of $50,000 plus probability of economic stagnation times the probability of stagnation plus 0, which is the payoff of recession, times the probability of a recession. We also do the same thing for sales with advertising. Substituting probability values into the formulas, we get the expected value for not advertising as $24,000, expected value of sales with advertising is $65,000. Clearly, given these probabilities, the decision would be to advertise. We always select the highest expected value. However, the quality of your decision depends on the accuracy of the forecaster. In the real world, you may want additional information. Indeed, you can purchase from a research firm an estimate what the future will be like. In other words, will there be stagnation, growth, or recession? They claim to have a much more precise estimate of the future condition of the economy. If you were to use one of these forecasters, you may have a more accurate probability on what the true outcome will be, and you have a greater chance of making the right decision. But here's the hitch. You want to know how much the information is really worth, and until you get it, you must pay for it beforehand. So you must decide if it is worth it to get this additional information, and more importantly, how much to pay for it. The more you pay for it, the smaller your overall profits will be. Without this additional information from the research firm, we can estimate our expected value as $65,000 when we advertise. But how much more would our profits be if indeed we had additional information?
We have information, we have and use additional information, and that's what Bayesian statistics is all about. But there's always that situation. Put yourself in a market research manager's position. Should you spend $20,000, $50,000, $100,000 on getting additional information in order to come up with your next crucial decision, whether to put onto the market a new product or design a new product? You're always concerned about what are the consumer's needs. But your first concern before you get that is, what are those needs? So you're going to have to find something out about the consumer. You're going to have to do some research. How much are you willing to spend? So you have, in turn, found some type of expected value given the current information you have. You get some type of return. Can that return be improved by getting additional information? And how much are you willing to spend for that research? If you find a situation where you're willing to spend, or you have $50,000 for a large research project, how is that going to affect, quote, your bottom line? Is your return going to be greater than that 50,000?
Before we go on, let's take a look at the way we will process this particular Bayesian analysis. First, we use the prior probabilities. We revise them using Bayesian analysis, and that's the firm's, forecasting firm's, past performance or record of forecasting. We'll then use the expected value rule. With these revised probabilities, we will get expected value of each decision given the information from the forecaster. Finally, we will subtract the expected value without the forecast from the expected value with the forecast, and we have what's called the value of the firm's information, or it's called with the acronym EVAI, expected value of additional information. Let's begin by using Bayesian analysis to revise our probabilities. You can get the research firm's past record from historical data and find out what they forecasted in the past and what really happened. We all have 20/20 hindsight vision. This is what we call our observation. Then, from this, you can derive conditional probabilities of the forecast defined as the probability of F given E. The economic condition is defined as E, and this, of course, doesn't really mean much because it tells us the probability of a forecast given the economic condition. But by using Bayesian analysis, we can switch the condition. We can determine the probability of E given F. Again, that's going on the probability of the general given the particular, as I mentioned earlier, for what's the probability of the economic condition given the firm's forecast. Let's look again at our graphic to see what we are doing. We have our conditional F given E. That's our historical data. We have our prior E, and we will form a joint probability, F and E, and from this we will generate new marginals for F, the forecast, divide the joint probabilities by these marginal probabilities F to get posterior probability of E given F. This is what we want, the probability of the economic event given the forecast. This is a kind of measure of the contribution that a firm's forecast can offer. With this information, we can estimate the value of that information and how much money we should pay for it. Let's try this out and see what it looks like. As we said before, we have forecasts for future economic conditions from reliable sources. These are our prior probabilities. Then we can find historical data on the firm, that is the forecasting firm, the research firm, that will tell us how the given research firm performed in the past in terms of its forecasts and how accurate they were. This is our conditional probability, F given E, or the forecast given the economic condition. Then we can construct a table that gives us the probability of forecasts for each kind of economic condition. Across the top we have each forecast, whether it was growth, stagnation, or recession. And on the left-hand column we have the economic condition of growth, stagnation, and recession that really took place. This is our probability table. Let's look how we have these now. These numbers can be used to compute posterior probabilities. According to our table, 80% of the time when growth was predicted, growth occurred. 10% of the time stagnation occurred, 10% of the time recession occurred. Similarly, the forecast of stagnation, 80% of the time they were correct, 10% growth occurred, and 10% of the time recession occurred. And similarly for recession, 80% of the time they correctly predicted recession, 10% they predicted stagnation, 10% they predicted growth. These numbers represent our conditional probability of f given e, or commonly referred to as our observation. Now we have our prior probability and the conditional probability of f given e. We can compute these two tables to compute the posterior probability. First, we have to know the joint probability. Clearly, the joint probability will be the product of the marginal times the conditional probability. Finally, the posterior probability, that's E given F, that is our goal. That's the probability of the economic condition occurring given the expert has forecasted. Let's go through 3 steps to show how this can be done. First, multiply prior probability by the conditional probability. Then we add each column of the joint probability now to find the marginal probability. That's the probability of F, of a forecast. Finally, we divide each box or each cell by its corresponding marginal probability to come with a new conditional probability table, probability of E given F, or the probability of the general given the particular. This is called your posterior probability. Of course, if you pay the research firm for its forecast, they will tell you whether it's going to be growth or stagnation or recession. But the problem is we want to know beforehand what are the possible forecasts that they can offer. So we have to look at all possible forecasts. We return to the expected value rule, but this time we substitute the posterior probability values for each possible forecast. Recall we will receive only a forecast for growth, stagnation, or recession. So use the formula for expected value and calculate the expected value of sales for each possible forecasted economic condition. Looking at our expected values in each scenario, if this expert forecasted growth, we would select to advertise and make $144.5 thousand. If stagnation was predicted, we would select to advertise and make $51.5 thousand. But if the forecast was for recession, then we would not advertise and we'd make $14.2 thousand. Finally, we can calculate the overall value of the research firm for each of the possible forecasts. We must use the marginal probabilities of the forecast, and we get expected value of using the company. We multiply the expected profit of our decision to advertise or not by the overall probability of the given forecast. Here are the expected payoffs for each forecast: 144.5, 51.5, and $14.2 thousand. Now we add the values together. We now have the expected value with this forecaster. If you recall our estimation of the probabilities of economic conditions, without the additional information from the research firm, the expected value was $65,000. With the research firm, the expected value is now $67,479. By subtracting the expected value without a forecaster from the expected value with a forecaster, we arrive at the value of additional information provided by the forecaster, which is $2,479. This is known as EVAI, expected value of additional information. Now we want to find the highest possible value of perfect information, or the maximum fee you should ever pay. Simply use your prior probability values times the maximum dollar amount you could make under each economic condition. This is called the expected value of perfect information. Subtract the expected value with no forecaster from the expected value of perfect information. This equals the maximum amount that you will gain with perfect information. In our example, it is $10,000. So there you have it. The highest we will ever pay for any research will not exceed $10,000. For this particular research firm, their research is worth at most $2,479. By using these rules and procedures shown in this program, Bayesian analysis can indeed make the difference in a loss or profit for the business world. Just think that by utilizing Bayesian analysis in the real world, you have an important edge over competition, i.e., when to hire a research firm and how much money are you willing to spend for the research effort. Clearly, you follow the rules and procedures, and you'll be able to succeed in maximizing the information gained for decision analysis. Thank you very much.